So let us assume that we have this as the overall output. So overall output means you will have a combination of the functions. Hello, can you hear me?
Yes, ma'am.
But my screen is stuck. Just a minute for some reason. I think I'll have to rejoin. Just give me 5 minutes. I'll rejoin. Sorry for the inconvenience. Okay, I'll share my screen. Yeah. So let us consider this as the overall output. So you have X and mu. Okay, this is one. And there are two fuzzy sets. And this, whatever I'm drawing, I'm plotting it on the same graph. So there are two fuzzy sets which are given to you. And we'll take the union of those two fuzzy sets. So this first one and this is 2 and 3. And the second one is again okay. So these are the two fuzzy sets which are given, and you have to apply all the defuzzification methods. Okay. So we start with which one? We'll start with the simplest method that we can have. Which method?
Mean of max.
Mean of maximum. So what is mean of maximum? Whatever is the maximum peak, from that you have to take the endpoints of that and take the average, right? That is mean of maximum. So it is basically, if I want to compute it, so what is a defuzzified value notation? X star. Defuzzified value is X star. X star by mean of maxima is nothing but the highest peak, which is one, this one. Okay. So you will have, what are the endpoints? These are the endpoints, 3 and 5. So it is 3 plus 5 divided by 2. That is nothing but 4. So by mean of maxima, it is 4. What else? Other simple methods. So basically, what is this 3 called? It is called as the first of maximum. And what is 5? It is the last of maxima. So under this mean of maxima, you can also have X star. First of maxima is 3. X star. Last of maxima is 5. And this is the simplest. Next, simple. Weighted average. Next one, we'll go for weighted average. Can you apply weighted average to this particular output? Tell me the answer. Can we apply weighted average to this?
फिगर इज नॉट सिमेट्रिक ना, तो नहीं होगा.
Weighted average is applied to the individual functions. It is not applied to the entire landscape, right? Weighted average is applied to the individual functions. Are the individual functions symmetric?
Yes.
So that means you can apply the weighted average method. Okay. So what is required as part of the computation of weighted average? You first need to compute the areas. No, you do not need to compute the areas. You just need to look at the center of that, of each of the fuzzy sets. Okay, so of this first one, you have to look at the center. Of the second one, you look the center. And then what you need to do? Multiply it with the membership values. Multiply this center with the membership, corresponding membership values, add it up. Okay, so the center of each function multiply with the corresponding membership, add them up, and divide by the membership sum, the sum of the membership. So that is the formula for weighted average. Okay, so let me call this as fuzzy set A1, and this is fuzzy set A2, the trapeziums. Okay, so A1, what is the center of A1?
2.5.
2.5, right? Center of A2, what is the center of A2? It is 4. Okay, so now you have to use just the formula. And what is the value at that center? What is mu at 2.5? It is 0.7. Mu at 4 is 1. So now you can apply the weighted average formula. So you say x star is equal to 2.5 multiplied by 0.7, the membership at that value, at x equal to 2.5, the membership is 0.7, and at 4, the membership is 1. And then what you do is you divide by the sum of the memberships. Okay, so what is the value that you get? Compute this. You should, whenever we are solving problems, you should have a calculator with you. What is the numerator? Four plus 1.75. Okay, so what is the answer? 5.75 divided by 1.7. What is the answer?
3.38.
3.38. So the defuzzified value using weighted average is 3.38. Next, which is the next faster, easier function? Center of sums. Do you recollect center of sums? What is center of sums? Center of sums. That means individual areas you have to consider. So consider A1 separately, A2 separately. You remember the overlapping region comes twice. It is counted twice, more than once, depending on how many are overlapping. So overlapping is region is counted twice. That is center of sums, but it is faster to easier to compute, right? So you find the area of A1, area of A2, find the centers of A1 and A2, find the centers of A1 and A2, and then it's similar to weighted average. Only thing is, instead of the memberships of each of the graphs, or of each of the membership functions, what you're doing is you're looking at the area multiplied by center. See, it's similar to this formula, weighted average formula. Only thing is, instead of the membership, what you're going to have is the area. Okay, so What is the area of A1? A1. It's a trapezoid. So what is the area? Half into sum of the parallel sides, right? That is 1 plus 3 into height. Height is this 0.7. Half into sum of the parallel sides into height, right? So what is the answer for area of A1?
1.4.
1. Next is area of A2. Same formula, different values. So half multiplied by these parallel sides, sum of these parallel sides, right? That is 2 plus 4 multiplied by height, right? That is equal to 3. Okay. And what are the centers? Centers you already know, 2.5 and 4. Okay. So what is the defuzzified value? X star center of sums is equal to 2.5 multiplied by A1's area, that is 1.4. 4 multiplied by A2's area, that is 3, divided by the sum of the areas. Here it was what sum of the memberships. Here you will have sum of the areas. Okay. 1.4 plus 3. So what are you getting? Tell me the answer.
3.52.
3.5. Correct. Fine. So these are the easy methods. Now coming to the difficult methods. Centroid method, a center of gravity, right? So how will we apply center of gravity here? Just a minute. Yeah. So center of gravity. Do you recollect what we had done for that? We are going to find out, you're going to use integral, definite integrals, right? You have the numerator, which is the sum of certain integrals divided by denominator, again sum of integrals, okay, to give you the centroid. So you have to use that formula. Okay. Okay. So numerator, what is the numerator? You have to look at the integrals. So this is first one is 1 to 2. Between 1 to 2, the equation of that line. So what is that? going back to that equation of this line, right? What is it? What is the equation of this line? Point 0.7 times x minus 1, right? Point 0.7 times x minus 1. Yes or no? This line. It's a straight line, huh? Okay. Multiplied by x. This is the numerator, so you have to multiply it by x. Okay. Then from 2 to the next point. What is the next point? From 2 to this point, intersection of these two lines. So intersection you can find out by substituting in this point in these two equations, right? And equate the two. You know how to find it, right? Tell me what is the intersection of these two lines. Can someone tell me what is the intersection? What is this point on the x-axis? That I want to know. Yes, what is the intersection of these two lines? What is this point?
2.7.
2.7, right? So how did you get it, Harsh?
वो लाइन के इक्वेशन में y का वैल्यू 0.7 डाला.
Correct, correct. Because this is clear. The equation of this line is y equal to 0.7. Just put that 0.7 in the equation of this line. So you will get 2.7. Okay. So from 2 to 2.7, what is the which equation you have to follow? This one, right? This equation, right? So what is that? Constant. It's constant. It is 0.7. 0.7 is the equation multiplied by x dx. Okay. Next is 2.7 to which point? What is the next point? It is 3, right? So 2.7 to 3, the next equation. That is this. What is that equation? It is x minus 2. It is x minus 2. The equation of this line is x minus 2. Okay. Multiplied by x dx. Then you go for next interval. 3 to 5. 3 to 5, it's a constant. Simple. So 3 to 5, constant is 1, right? So 1 times x dx. Just right. Next, from 5 to 6. From 5 to 6, it's the equation of this line. So what is the equation of this line? Can someone tell me?
Six minus x.
6 minus x, correct. Multiplied by, okay, and we are done. So this is the numerator. Okay. Now when you are solving this, you just have to use definite integrals and solve it. Okay, so let us solve it. Let us get the value for the numerator. So just substitute it. So you have to be careful when you're using this method. If this method is asked, you are bound to make mistakes. Okay, so 0.5, 0.7. This is x square minus x. If I open it up, okay, so So it will be, let me take this outside, right? For this particular integral. Okay. So it is x cubed by 3. The integration, this is x square minus x, right? So x square integral is x cubed by 3, right? Over this interval. And you have minus x. So that integral is x square by 2. Okay. So from 1 to 2. Then the next term is this range. So point, sorry, point 0.7. I'm taking it outside for this term, 0.7. And then what is the integral of x? It is x square by 2, right? The range is 2 to 2.7. Next, this one. Okay. So it is, if you open the brackets up, it is x square minus 2x. Okay. So what is the integral? So x square integral is x cubed by 3. X square integral is x cubed by 3 over the range 2.7 to 3. Minus sign in between. Okay. Minus sign in between. 2 times x. X integral of x is x square by 2. Okay. And this is the range 2.7 to 3. Okay. Next integral. Next integral is from 3 to 5 x dx. What is that? X square by 2. 3 to 5. Okay. Next, last one. Again, it's a big term. So first one is 6x. So 6x is 6 integral of x square by 2, right? Over the interval 5 to 6. Okay. And the second term is x square, integral of x square, that is x cubed by 3, right? So these are your integrals. These are the values. Now you have to evaluate by using the limits, right? So if you open these brackets up, I've given you the equation. Now you tell me, just solve it and tell me what will you get as the value for n. What are you getting? This is the final equation. Someone is verifying it. Is it correct? There's a mistake. Right? Open it up and tell me what answer you're getting. It might take you 1 or 2 minutes. Find it. What is 27 square?
7 to 9.
7 to 9. So you can write 7.29. Okay. Next. Just break it up. Just find out. Three cubed. 3 cubed is 27. 2.7 cubed. 27 cubed.
One nine 683.
19683. Right. 19.683. That is. Okay. So actually 27 minus 19.683, right? 3 cube minus 2.7, right? Then what else? Again, there's a minus sign in between. So this 2 gets cancelled out. So again, 3 threes are 9. 9 minus 2.7 square. 27 square is it? Again, right? And then this term. Next term is x square by 2. So it is half of 25 minus 9. Okay. 6 times this term. Now this term. 36 minus 25 minus 1/3 of 6 cube. What is 6 cube?
216.
216
6.
and 5 cube.
125.
मैम वो सेकंड लास्ट टर्म में 6/2 आएगा 36 माइनस 25 वाले में
6/2. So this is 3, right? Next, now you find out 0.77/3. What is this term? This is 7/3 minus 3/2. Whatever you're getting. What are you getting? Minus 9 minus, it was minus, this will be 9 minus in bracket. Minus sign is outside. So it is minus 2 point. This is 7, 1.
One 1.7.
1.7. 1.7. Right. 25 minus 9, 16. 25 minus 9. 16 by 2. Right. That is 8. What about this? 11. 11 threes are 33. 216 minus. What is the final answer you are getting? Can someone tell me?
Ma'am, I'm getting 13.12, but I've done it thoda differently and I'm not sure.
मैम मेरा 13.1305.
हाँ same.
1305, na? Yeah. So this is the numerator. Okay. Denominator actually is the area under that curve. So you don't have x, you only have the equations of the lines. Okay. So let us do the denominator also, because denominator we are going to use this denominator actually. We can use this to compute the fuzzy defuzzified value using bisector of area. So we want the equations, I want the equations of the denominator areas. Okay. So let us do the denominator more carefully. For bisector of area you'll require. The same equations will come here. Only thing is x will not be there, right? So I'll write the equations. It is 0.7 x minus 1. 0.7.
Ma'am, can we simply find the area from the graph instead?
You can find the area from the graph. Yes, you can find the area from the graph, and then you will have to use the sum up till that. I mean, you need the areas individually like this. Why I am finding this is because I need to know at which point my bisector is cutting. I mean, which graph my bisector is cutting, because I do not know now that point. See, that bisector, I do not know where it is cutting the x-axis or some particular membership function. So what will I do is I will find out the areas individually using the equations. See, the idea behind bisector of area is what I will do is individual equations I will take. So what is the meaning of this integral of this equation? It means the area under this line. Integral of this means what? So if I'm talking about integral between these 2 points of this line, it means the area under this, right?
Yes.
So what this idea I'm going to use. So this is first area, this is second. So up till from this 1 to 2, this is the first area. From this to 2.7, whatever it was, that is the second area. Then third area, fourth area, and fifth area. So 5 areas I'll get. Okay. Now what I will do, once I get the area of this region, you use any method, I don't mind. Once I get the area of this region, I will half that area. Okay, because the total area, see, what is that equation? 0 to x square, whatever, that left value, L value. Say it is A and B. This is A and this is B. Okay, so it is 0 to x star, that mu, the area. Left, this is the left area, should be equal to x star to B, the right area. This is right. Right? So that means total area is this plus this. Or I can say twice of this, twice of any one of this is equal to the total area. Right? That means what? Half of the area is equal to any one of these integrals.
Yes.
So the idea is I need to keep on finding where my area is exceeding that, the sum of the areas that I found up till now is exceeding that half of the area. The moment I find that it is exceeding, at that point I know that bisector lies in that range. Are you getting it? So suppose this area is something, this area is something, I keep on adding.
Yes, I
एक
understood
point.
that.
हाँ.
But in the exam, can we just go ahead and find it graphically? Because as it is, पूरा area तो नहीं निकालेंगे ना, triangle, rectangle वही निकालने वाले हैं, area भी.
So you mean to say for this particular centroid method?
If ma'am, for any method. Because you take the area part by part ना, जैसे 1 to 2 का triangle है,
Yes.
पहले वो ढूंढेंगे, फिर वो छोटा rectangle ढूंढेंगे, फिर वो
हाँ,
line के नीचे का
that is up to you how you divide it.
हाँ, that's fine ना.
That is also fine.
Okay.
So even if you go by that method, then the integral of that equation you have to take. समझ में आ रहा है ना आपको?
हाँ हाँ मैम, सेम ही होगा ना, इंटीग्रल वाला ही पार्ट का.
हाँ हाँ हाँ. Then you will get that equation in x star, and then you will find the value of x star.
Yes.
Okay? So I'll just tell you that for now, whatever I have solved, according to that, I've used integrals. So I will just write the equations, the final area that I've got. So I got the area of the denominator. This denominator term is nothing but the area. Okay. So area of the entire curve, I got it as 3.595. Okay. So half of that area. What is half of the area? It is 1.7975. Okay. And the areas that I've got, the 5 areas that I was talking about, A1, A2, you have understood now what is A1, A2, A3, A4, A5.
Yes, ma'am.
Okay. So I will just write the individual areas that I've got as per the integrals. Okay. Here. So I got it as A1 is 0.35. A2 I got it as 0.49. A3 I got it as 0.255. A4 I got it as 2. And A5 I got as 0.5. Okay. So I come to know where am I reaching this 1.7975. I always have to compare. So I add it cumulatively. I start from leftmost area. So I add it. This plus this plus this, it's still less. So at this point, when I add this, right? What is this plus this plus this? It is 1 point something. Okay. And when I add this, it becomes more. It exceeds. Okay. What is the meaning of that? Whatever is the range of this area. See, up till this point, I have not equaled half the area. Up till the sum of these two areas, I have not equaled this particular figure. Okay. So this particular figure I'll get exceeding this. Okay. So what does this mean? What does this imply? My bisector is lying in this area, A4, and A4 is nothing but 1, 2, 3, 4. So bisector is lying between 3 and 5. Tells me that the bisector is lying between 3 and 5. And since the bisector is lying between 3 and 5, what do I need to do? 1, 2, 3, I have the areas. This area I have, this area I have, this area I have. So I need to write this kind of an equation. What do I say? I write is whatever is the sum, this sum. Okay. I start from 1 to x star. Actually, my function is starting from 1 to x star. X star is the point that I need to find. Is equal to mu. Okay. Mu of x. That I will write is equal to 1.7975. Correct? Now, I know 1 to 2 what is the area. 1 to 2 what is the area. 2 to 3 what is the area. 3 to 4 what is the area. So it is 1 to 2, 2 to 3, whatever, 2.7 jo bhi tha. Okay. (2.7 to 3). This was 2.7. I know the areas, these values. That is A1, A2, A3. Okay. Plus, I say 3 to x star. So I say 3 to x star. I don't say 3 to 5 now. I say 3 to x star because I need to find that x. my bisector is lying somewhere in between 3 and 5. So I say integral from 3 to x star mu x. What is the equation of that line? I write it. So that equation is, it's a line parallel to the x-axis. So what is that equation? It is 1, right? Yes or no? This is equal to 1.7975. And what is the sum of this? It is 1 point something. 1.095. The sum of this is 1.095. And now I'll simply write my integral formula. So this is dx. Dx is what? X. 3 to x star. Right? This kind of an equation I get. So it will be x star minus 3 is equal to this. I'll take it here. So it is some 0.70. 0.7025. 0.7025. Okay, and so x star is equal to 3.7025. That is what I've got. Fine. So this is how you will use the bisector of area method. You need to have the area.
मैम हेलो
Yes.
मैम, ये हर केस में करना तो पॉसिबल नहीं होगा. फॉर एग्जांपल अगर दो बेल कर्व्स है तो पता कैसे चलेगा कि वो एक्स स्टार राइट वाले पे या लेफ्ट वाले पे या दोनों के बीच के इंटरसेक्शन के कोई पॉइंट पे? मतलब इसमें तो ऐसा हम लोग को क्योंकि लाइन से तो ऐसा पता चल गया 5 एरियाज, और फिर हमने वो क्यूमुलेटिव सम करके पता मतलब अप्रोक्सीमेटली फाइंड कर लिया कि कहाँ पे वो लाइन होएगा. A4 के
बेल कर्व का
होएगा.
इक्वेशन रहेगा ना आपके पास.
हाँ, तो बेल कर्व का वो इक्वेशन जो मतलब अगर दो बेल कर्व है तो हमें हमको हमेशा उसके यही पता है कि दोनों में से किसी एक को हिट करेगा, या फिर बीच में भी हिट कर सकता है दोनों के एग्जैक्टली बीच में, या फिर वो जहाँ पे इंटरसेक्शन करते तो वो राइट और लेफ्ट में इंटरसेक्शन के वो जो पॉइंट रहते हैं वहां पे भी. तो फिर वो
तो एरियाज आप वहां तक ही लोगे ना. सी इफ यू आर डिवाइडिंग, see when you're dividing it this way, I'm considering these points na. In that bell curve also you will take those points na, so you will know the left hand side का equation क्या है, right hand side का क्या है. तो point तो कहीं पे भी इधर एक ही जगह पे आएगी ना. दोनों possibility कैसे मिलेगी आपको?
अभी वो ऐसा इधर बता नहीं पाऊंगा मैं. मतलब आप अगर दो बेल कर्व बनाओगे जो इंटरसेक्ट कर रहे हैं और बीच में वो इंटरसेक्ट करेगा, तो टोटल मतलब वो एक्स स्टार या तो राइट बेल कर्व पे लाई कर सकता है या तो लेफ्ट बेल कर्व पे लाई कर सकता है. ऐसा
दो बेल कर्व बना रहे हो.
हाँ.
दिस इज वन बेल कर्व.
हाँ, और दूसरा इंटरसेक्ट करो उसके. हाँ, एक और बनाओ.
हाँ.
तो अभी एरिया जो होगा वो बीच में जो इंटरसेक्शन पॉइंट है वहां तक का राइट लेफ्ट का मतलब जो भी स्टार्टिंग पॉइंट से लेके वो इंटरसेक्शन पॉइंट तक का
तो
इंटीग्रेशन.
एरिया में ऐसे 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 पकड़
हाँ.
रहे हो ना आप.
हाँ, तो अभी जो
दिस
एक्स
इज
स्टार
सम
है.
पॉइंट, दिस इज सम पॉइंट, दिस इज
और
रिमेनिंग
सी.
लास्ट.
हाँ, एंड सी.
राइट.
यस. अभी हम लोग
अभी
को
इसका इक्वेशन पता रहेगा ना आपको.
हाँ, दोनों बेल कर्व का इक्वेशन पता है. तो हमारे पास दो एरियाज है, A1 A2.
नहीं नहीं नहीं, इसका इतना इक्वेशन
वो
इक्वेशन
B.
विल बी फ्रॉम A to B ना,
हाँ.
ऑफ दिस बेल कर्व.
हाँ.
बेल कर्व 1
यस.
and from B to C
For-
bell curve 2.
हाँ. तो अभी
Right.
हाँ.
So ऐसी एरिया मिल रही है ना. दिस यू आर गेटिंग वन एरिया,
यस.
दिस यू आर गेटिंग अनदर एरिया.
यस.
Right. So if I use the same, and that is equal to the total area.
यस.
So if I'm using the same equation, so I will
अभी इसमें एक्स्ट्रा.
I will come to know either it has gone here or it is here ना.
हाँ, तो वही हम लोग को दोनों देखना पड़ेगा ना.
अरे बाबा, अगर ये एरिया सपोज कुछ
अगर
है,
अगर एक्स स्टार राइट वाले बेल कर्व पे लाई करता तो फिर हमारे पास दो आते, एक ए से एक्स स्टार राइट B1 और एक्स स्टार से B B1. और फिर बाकी का एरिया। और अगर ये जो अपना एक्स स्टार अगर सेकंड वाले बेल कर्व पे लाई करता तो आता है ए टू बी एरिया ऑफ B1 और फिर B टू एक्स स्टार ऑफ B2 और एक्स स्टार टू सी ऑफ B2। तो मतलब दो पॉसिबिलिटीज आ गई और शायद बीच में भी लाई कर दे एक्स स्टार बी पे ही एग्जैक्ट।
आप ये एरिया फाइंड आउट कर रहे हो ना, और आप ये भी एरिया फाइंड आउट कर रहे हो सेपरेटली।
हाँ
तो जब आप हाफ ऑफ एरिया फाइंड आउट करोगे तो आपको पता चलेगा कि वो हाफ इसके अंदर आता है कि इस एरिया के अंदर आता है।
हाँ
तो उससे मिल जाएगा ना आपको।
हाँ सही लग, हाँ ठीक है ओके।
हाँ, एक बार ट्राई देखो फिर से क्या
हाँ
बोल रही हूँ मैं, बिकॉज वी हैव अ
समझा
डिस्टिंक्शन। एम्बिग्विटी नहीं कि हम इसको अलग फाइंड करें इसको अलग फाइंड करें, वो हमने निकाल ही दिया ना यहाँ पे।
यस समझ गया।
मैम
Okay.
सेंटर ऑफ ग्रेविटी का आंसर क्या है?
13 पॉइंट क्या मिला आपको? 13
नहीं फाइनल आंसर दैट विल बी डिवाइडेड
जस्ट
ना।
हाँ, जस्ट लेट मी चेक। अच्छा, यू आर डूइंग बाय अदर मेथड क्या सागर?
नहीं मैम मतलब 13.1305 को वापस डिवाइड करेंगे ना।
13.1305 divided by this denominator that I told you, na, area that I got.
3.595.
3.595, yes.
Yeah, so that is approximately 3.65. So that will be the answer of center of gravity.
Exactly.
And by bisector, we are getting 3.7025.
Yes.
Okay. And ma'am, for the center of largest area also, we can use in this one, right?
Now, center of largest area can be applied. Now, what happens in this case is, if it is non-convex, then you have to divide into convex regions and apply the centroid method for the largest area. That is the idea of center of largest area. So if this is the entire region, is it non-convex?
No.
No, it is a convex region. Since it is a convex region, center of largest area is equal to the entire area, the centroid, the answer that you got by centroid. Because what center of largest area does is, you divide the non-convex region into convex subregions. And from these convex subregions, you find out which convex subregion has the highest area, the largest area.
Got it. So entire thing will be the convex subregion.
Yes.
Okay.
So whatever answer you got by centroid method, that is the answer for center of largest area.
Achha, samjha.
And one more thing is that when there is convex, the only defuzzification method that will not work for non-convex is the weighted average method. Okay, rest all will work because there is no problem with the convexity of a particular output that you're looking at. When you're talking about center of largest area, if you're using that, then it has to be non-convex. Then only you can divide it and do all that. Otherwise, it is equal to centroid. Okay.
Yes.
So the drawback of weighted average is very fast, but the drawback of weighted average is it requires convex and symmetrical individual functions, MFs. Okay, and there are many others which have been proposed. It is not that these are the only ones. In fact, when we talk about fuzzy inference systems, there are different types. Like there is Mamdani fuzzy controller, which is the oldest, and then there are some others also. Sugeno and Tsukamoto, Japanese, these scientists have actually proposed these FISs, fuzzy inference systems. And the kind of rules that are there and the kind of defuzzification methods that are there, they are different in each of these. So for as far as the syllabus is concerned, we will be focusing on Mamdani, but I'll give you an overview of the other two also, how it is different from the Mamdani system, so that you can just go ahead and study if you are interested in that. Okay. So I'll stop here. Any other doubts you have?
मैम जस्ट अ क्वेश्चन, वो
No.
जो बाइसेक्टर है वो सेंट्रॉइड के थ्रू ही पास होगा ना हर एरिया के लिए?
नहीं, अलग आंसर मिला ना आपको.
बाइसेक्टर के लिए कैलकुलेट नहीं किया इसीलिए पूछ रहा हूँ।
हाँ
नहीं
अलग है, हर्ष अलग है।
नहीं नहीं, बाइसेक्टर और वो एरिया को डिवाइड करता है, ये सेंट्रॉइड है ना। आप
ओके ओके
सेंटर बोलते हो, वो जैसे बाइसेक्टर क्या होता है, आप ट्रायंगल का बाइसेक्टर सॉरी सेंट्रॉइड फाइंड कैसे करते हो? यू कैन,
परपेंडिकुलर बाइसेक्टर्स बना के ना।
हाँ तो वो उसमें वो है ना 2/3 ऑफ हाइट, वो सब फॉर्मूला है ना। सो
ओके
किधर
ओके
बीच में वहाँ उसकी डेंसिटी देखता है वो, तो वो इट इज नॉट नेसेसरी दैट इट विल कम सेम।
ओके